GIS. GIS includes, so many fields. These are all, small tools to perform one entire process of GIS analysis for any kind of application. So it includes digital mapping, photogrammetry, surveying, remote sensing, of course, databases, and then computer aided designs. So computer aided designs are nothing but simply, to perform any GIS task, we can have we should have so many softwares, so many tools to perform such analysis. So one demo we saw was a Google Earth Engine and QGIS. So all these are computer softwares. Digital mapping, in previous days also there used to be maps, right? Surveyor used to visit that particular area. They used to, work all day, and they used to make the mapping on paper, right? We call it topo sheets. Now only from Survey of India, if we will get it, we will get handmade maps in topo sheets format. Okay, so that was how it used to look when we talk about mapping. Now it has turned digital, so we call it digital mapping. We will get to learn about digital mapping and its elements also in further slides. Then photogrammetry. Photogrammetry simply means that it basically uses photographs. So photographs can be of any kind. It can be an aerial image, it can be a drawn photograph. And with the photograph, when we combine particular data of that feature, then we can use it for GIS analysis. So photogrammetry means capturing data using photographs. Then surveying. Surveying is again important. See, whenever we use any kind of satellite data or any digital data, we don't get 100% accurate output. You understand this? This is model data. There are number of problems related to satellite images or any kind of drone data set or any other kind of image or aerial data. So surveying is actually important to get the actual output. We have GPS devices also in any government sector. If you will go, or any company working on GIS, you will get GPS data. So sometimes it happens that to get the exact output, we have to have the GPS data, and we have to take a look of the area on which we are working to get the accurate output. So that is one thing, surveying. Also, as I spoke about population thing, right? In my emission inventory work, what we used to do was to monitor and count vehicle. While standing on a junction, we used to count number of vehicles. What is it? It's surveying. I want to, in villages, I want to measure the pollution through the industries. Then I have to have data of whether here households are using some other fuel than LPG. Are they using wood or anything? Then what I had to do was survey. Okay, so survey is again one major part of GIS. Then remote sensing, of course, we had already studied about remote sensing. We got enough information about it. Then there are databases. Okay, so this is again important. Working with database is one entire different level of expertise when it comes to GIS. Okay, there are so many databases, SQL database, Oracle database. For storing the special data, we prefer PostGIS or Postgres data. So there is a database called PostgreSQL. We work with it. It can store a large amount of special data. And maintaining database is one of the biggest tasks in GIS if you want to work with GIS. So if in India actually we have started now to gather geospatial data. Otherwise, if you really want to work uh, in India for GIS things, then you will find that there is a lack of geospatial data in our country, because for some, I think for the state of Odisha or somewhere, they have their website which gives geographical data publicly available, using which you can prepare maps, or you can use it for further analysis. But for all over India, you won't find such database. So actually, it's in our country, it's required for now to work on database creation and to maintain it. Okay, so all these things are associated with GIS, and we'll learn it. So yeah, basic, if you want to go by the definition, then geographical information system is an information system that is used to input, store, retrieve, manipulate, analyze, and give the output in geographically, georeferenced and geographical format of the data. Okay. So it is a facility for preparing, presenting, and interpreting facts that pertain to the surface of the earth, right? So as in short, if I'll tell, as I told you, that data which has the location information are called GIS data, and we will be able to analyze, manipulate, retrieve, and store such database are all part of GIS, right? So this is one nice question actually. When we talk about geospatial, then how can we call that it is a locational data? It is a spatial data, right? So now we have this point, right? You have the point. This is the point. Now you should have a place name. You should have a postcode. Distance and bearing, it's not that important, but for further analysis it might be useful. You should have a description of it, and most importantly, you should have latitude and longitude associated with it. Okay, the point of that Regal Cinema, okay, that we extracted from the Google Earth, and then we imported it in QGIS, right? So in QGIS, and then we had a shapefile of India. You could see that point near Maharashtra. Why it was like that? Because it had some location information. It had location information which was showing that the point is in and around Maharashtra. Okay. Otherwise, we would not be able to, perform the intersection analysis, whether the file is intersecting with Maharashtra or not. No. How will it find if it is not having any kind of locational information, right? So latitude, longitude should be there in the data. This is one of the most important thing. And there is a grid coordinate. Okay. So when we talk about coordinate, it's not only latitude, longitude. There are so many terms which comes first, and first of all is datum. Okay. So it's very basic and primary thing that long back when we started using geospatial data, we had decided datum, which was WGS 84. So datum is one kind of a reference point. Okay. How are we getting coordinates? Is that we are getting latitude and longitude on the Earth's surface. So we decide one point from which everything spreads on the Earth's surface. Okay. And there we are getting longitude as well, and then we are getting particular numbers. So that is how the particular location was being decided on the Earth's surface. And also, to simplify it, we have so many projection systems also with us. Okay. So one is geographical projection system, one is elliptical kind of projection system. In GIS, we consider Earth as geoid. Okay, there were many theories in which it was ellipsoid. Somebody was considering it round, but finally we call that shape a geoid. Then in the geoid, if we want to get the location information, we try to fit the geoid in the cylindrical form. We try to fit the geoid in elliptical form. Based on it, it started that there are so many coordinate system, created by different people. Some of the universal coordinate systems are, datum WGS 84, that which we use, and geographical coordinate system some we use, and some are regional as well, which is designed particularly in the particular area, to assign to any kind of data set in that area, right? So grid coordinate is one of the important things. First of all, you have to have the projection system decided for your data, and then based on that projection system, you will have latitude and longitude. If you have geographical coordinate system, then your latitude and longitude will be in degree, minute, and second unit. Okay, if to simplify it, if you have converted it in projection system, means it is on the planar surface, so now it will be in meters. Okay, so basic functions of GIS. Actually, we have already spoke about all this. Data acquisition and processing. So digitizing, editing, topology building, projection, transformation, formation, and conversion, etc. So digitizing, what we did here is that we took a point from Google Earth Engine. Likewise, we could we could take some area of some water body by creating polygon boundary around it. We could take out line by digitizing some road area of it. So whenever we are creating boundary of particular feature, and we are taking that particular feature in out of the Google Earth or from any data source, then we call it digitization. Okay, to digitize is to define the boundary and create a shape. Then editing, after if we have some polygon, if then we have imported it in QGIS, we can cut the polygon, we can resize the polygon, we can little bit compress it, all kind of thing if we are required to do, then it is called editing. Then topology building. Topology building is topology is when we have so many features in one frame, in one area, then to maintain particular distance between two features, or to check whether features are overlapping or not, or to make create symmetry, so it's called topology building. If some breaks are there while digitizing, then we have to fix it, so it's called topology building. Then projection, now only I spoke about projection, right? That we have to project the data, we have to assign some projection system. Can it be geographical? Yes, it can be, and also it can be planar, right? Transformation, if we have to do any kind of, mostly transformation is not required, because it's like we have reprojected, then only the task is done. Okay. Format conversion, like we did right now only, right? From KML we changed it to SHP format, so we converted it in SHP format, and how that is how we could use it for further analysis. Okay, now data management and retrieval is, this is all about database thing. We can have network modeling and relational modeling and attribute query, any kind of database we can create and we can maintain it. For that object oriented database also we can maintain. and we can maintain it in, as I told you, Oracle and PostgreSQL or any kind of database, from which we can directly use it in QGIS format, or we can do manipulation in database itself, right? Then special measurement buffering. Now only I think you I saw you the you guys saw, right? Buffering. So when we had a point and we wanted to create a 100-meter circle around that point, we used buffering. So like that only, if we want to plant trees on the side of the road, then what we do is that we have the shape file of road, and we say that like it should be 1 kilometer away from the edge of the road. So what we do is that we create the buffer, and then we decide the spaces where we can plant a tree. So that is how buffering we use. Buffering overlay operations. Overlay is when there is one layer on overlaid on the another layer, then we can do overlay operations. It should have attribute data and everything with it as well. Okay, the graphic output and visualization. It's all when we finally prepare the map, we will use this. So like I'll show you example of map in future slides. Okay. So this is classification of GIS data. Now only we understood there are graphical data and ancillary data. So all the shape file we can say point, line, polygon, all this vector data are part of graphical data. Raster data are also part of graphical data. Okay. Uh, Raster data and vector data are both part of graphical data. We can see it as graphics, and then another one is ancillary data. Ancillary data, we can call it metadata as well. It's information which comes with graphical data, right? Like the example I gave in between, that when we have a shapefile of so many houses in one particular area. Okay. So say one city, say I did the analysis when I was in Paniput. So say one city is there in which there are 10 houses, and we want to find that how much of density is there. For that we have to count the population, and for that we have to have some kind of ancillary data stored with the particular house. So using that data, we can do further analysis. So this kind of data is called ancillary data. When we have any kind of raster data is satellite image. All the satellite image that you saw in remote sensing portion, those data was had the data type of raster, and it had the extension of TIFF file. Okay. So all this information is important, because whenever you actually want to work with GIS software, you should have data in particular format with particular extensions to work further, right? So all this kind of data are being used for GIS analysis. Okay, right? Now these are the element of maps. Okay, if you will see elements of maps here, it's like cartography. You know cartography. Cartography simply means to make map. Okay, art of creating map is called cartography. So what perfect cartographer ensure in his or her map is to have all these elements. Okay, tall dogs is it's simply a short form, it is not a word. So a map should have a title, map should have a author name, legend. Legend is when you create a map and you decided which signature is there for which feature. I'll show you, actually I'll show you the map in which you can see legend. Then it should be clearly readable, easily everything. This is just normal thing. then you have to have a date of creation of that map, so that if you want to do the change analysis or time series analysis, you can keep track of it. Okay. Orientation means whether it's northward or southward. So mostly we make maps northward, so we have to keep a north arrow in the map. Okay. Okay, fine. Yeah, so this is the last thing, that you have to if you want to work, then you can use this many softwares to do the GIS analysis. Okay, so now I think it's all clear. I think you guys understood remote sensing, GIS, and GPS also. We took in the introduction section. And in GPS also, I also don't have much to say, because GPS is specifically a global positioning system, and it's a kind of navigation system which is being used in GIS just to take the locational data, right? So this is all in remote sensing, GIS, GPS. If you have any doubts, you can ask. Yeah.